Okay, 3.4, day 3. Today we're going to tackle the word problems from chapter 3, section 4. All right, so we know, let's go back, I'm sorry. Let's look at the formulas that we have so far. Okay, so we know these formulas are financial formulas that we'll be using. We have the first one, amount equal principal times 1 plus the interest rate in decimal form over the number of times compounded, and same number of times compounded times t in years. And that's if it's compounded monthly, quarterly, annually, etc. And then we have our other formula, amount equal principal times e to the interest rate times t, the number of the years. That's when it's being compounded continuously. Okay, so we have to look and find what are we given? Okay, first of all, continuous compounding. So we use this formula. And that was the first thing that stood out to me. Now, let's go and read the thing. An initial investment of $200. So initial, whoops, that's the wrong formula. It's A equal. So an initial investment of $200 is worth $315.24 after 7 years. Find the interest rate. So the variable we'll be looking for is R. So the initial investment of $200, that's the principal. The amount at the end will be $315.24 after 7 years. So T equals 7, and I'm trying to find R. What is the interest rate? So I substitute everything into my formula. A is 315.24 equal my principal times E to the 7R, right? 7 is T, R we don't know. All right. Divide both sides by 200. We need to isolate the E variable. So I divide both sides by 200. All right, now I need to take the natural log of both sides because I need to use the inverse operation of an exponential base E. So I'm going to use the natural log on both sides. That cancels, and I get the natural log 1.5762 equals 7R. Now divide both sides by 7. Equal to R. So R is about 0.065. So change that back to a percentage, and that 6.5% is our interest rate. Final answer. Okay, let's do one more here. An initial investment of 200 is now valued at 254.25. The interest rate is 6%, compounded continuously. How long has the money been invested? Okay, so continuously, I'm going to use the same formula that we used above. My principal is still principal investment, still 200. The amount at the end is 254.25. My R, change it to a decimal, 0.06, and I'm looking for my T. Again, let's do the formula. Amount 254.25 equal 200 times E to the 0.0606 T. Again, isolate the E, divide both sides by 200. and I'm going to get 1.27125 equal e to the 0.06t. Take the natural log of both sides because I want to undo base e. So I get the natural log then of 1.27125 equal 0.06t. Go over here now, finish it up. Divide both sides by 0.06. Natural log 1.27125 divided by 0.06 give me my t. My t is approximately 4 years. Let's do another one. You have deposited $500 in an account that pays 6.7% interest compounded monthly. How long will it take your money to double? Since we're compounding monthly, I'm going to have to use a different formula. Amount equal principal times 1 plus the rate over n t. Okay. How long will it take your money to double? So if I'm depositing $500 in an account, that's my principal. My rate is 0.0675. How long will it take? That tells me I'm looking for t. So the only other variable I need to figure out is the a, because my n is 12. Well, if my money's doubling, I have to take my principal investment, and I want to double it. So my amount at the end would be $1,000. Plug it into the formula. 1,000 equal 500 times 1 plus 0.0675 divided by 12 times 12t. Okay, so now we have to isolate the exponential base. So I'm going to divide both sides by 500 and I get 2 equal. I'm going to calculate this out and that becomes 1.005625 to the 12t. Take the log of this with this base on both sides because I need to get rid of that. So I'm going to use log base 1.005625 of 2. Same log on both sides. So simplify. Now divide both sides by 12. I know it's kind of long. And that will give me my t. Because this side here is now is 12t. So I divided both sides by 12. And my t is about 10.3 years. What if I'm compounding something continuously? So that's the first words that stood out in my mind. So I need to use this formula. How long will it take your money to double in an account that pays 3.2%? So I don't know how much I'm investing or the amount yet. I'm going to discuss that in a second. So I'm going to change this rate to 0.032. I want to know how long will it take, so I don't know t. Now it says my money to double. So let's just pretend I invest $1, and if I'm asking for it to double, my amount would have to be $2. Keep the numbers easy. So we get 2 equal 1 times e to the 0.032t. Well, when I divide both sides by 1, it's just 2. So I don't really need to write that there. Now, since it's base e, let's take the natural log of both sides. That simplifies, and the left side would equal 0.0 natural log of 2 equal 0.032t. Divide both sides by 0.032. That will give me my t, which is approximately 21.7 years. That would take for my money to double in an account that's compounded continuously that has a rate of 3.2%. Last problem, it's a modeling problem. For selected years from 1985 to 2004, the average salary Y in thousands of dollars, okay, that's going to become key, for public school teachers for the year T can be modeled by the equation. Okay, so given this equation, we can figure out information. T starts at 5, okay? T represents 5, which represents 1985. That'll become key at the end. During which year did the average salary for public school teachers reach $44,000? Since up there it says in thousands of dollars, I could use 44 to represent 44,000. So I could say that my Y is equal to 44. The only other variable I don't know is T. That's the time, the year. So I start substituting in. So I need to isolate that. So I'm going to add 1.562 to both sides. Okay, so I still need to isolate that. So now I'm going to divide both sides by 14.582. And I get 3.124 approximately is going to equal the natural log of t. Now, since I need to solve for t, and it's a logarithm, I'm going to exponentiate both sides. So t is approximately 22.74. Now, here comes I got to think this through a little bit more. Here's the logic. Since t equals 5 already in 1985, so I've used 5 of my t's already. So if I've used 5 years in 1985 was 5 years, then I need to go back and say, take 5 years off of this t, because I've already used 5 of them. So since it already used 5, it is 17 years. After 1985. So in 2002, the average